Okay, welcome to the sixth video session on CEC S2C programming in C by Computer Science Department of College of Engineering, Chengannur. We will continue from where we have finished last day. Meanwhile, we will talk a few minutes about two major file types. While processing data, we have till time assumed that the file is a text file. A text file or any other file, say binary file, the other classification is a binary file. Text file or binary file, both are in underneath whatever we see on the screen, all are stored as bits, zeros and ones. But text file is called a text file because 8 bits or 1 byte constitute a character, and a file which is interpreted as a collection of 8 bytes streams or a collection of bytes is a text file. So every 8 bits will be considered as a single unit or as a character, and they will be interpreted, and the corresponding character mapping will take place. That is 2 raised to 8 is equal to 256. So 256 different characters that include the capital and small alphabets, numbers, other punctuation symbols, and so many other special characters. So all these will fit into the character set. So a text file is is a collection of bytes, collection of characters. So every 8 bits will, again repeating, will form a character, a byte, and the byte is interpreted as a character, and text file is interpreted. So the file is every 8 bits or every byte will be treated so. But binary files is actually a collection of structures. So it may not be, the boundary may not be at the top level, the boundary may not be 1 byte each. One record will be separated, and once the record is separated, we may process it as text or other things. Okay, so we here today we will learn about binary files as well, how to read and write binary files. That means we could define a structure, and we could write a structure, and we could read the structure extra. So we will, it is user defined, that the format is user defined. So different file formats are there, standard file formats are there for audio and video and PDF, or for different formats are there. These all are defined, and they are called binary files. And even beyond that all are standard accepted file formats. Even beyond that, the user could define file formats. We could create a file with the structure or the format we are defining. If someone else is reading that file, that person may not be able to easily interpret what is written in this particular file. If we know that, or if the other person know the structure of what is written, then he will be able to read and interpret the contents, whether it is a string or how many bits are there extra. So the two operations that we have discussed is actually not meant for text file. It is meant for binary files. So fread and write will read and write streams of bytes into the file. So for next level interpretation is left to the program. But for text files, we have other operations. So when we tried to process the text file using fread and write yesterday, there wasn't the major issues, but you might have noted at one point. Okay, now we will share the screen and continue the explanation. Okay, we will share the screen. The first program that we have tried yesterday. I think it was file read, right? Okay, let me check. Yeah, the first program. Okay, it was FRW, cat FRW. Let us see that FRW.c. That was the first program we have tried yesterday. Okay, you might have noted that we have read the file. Okay, this is we have opened two files. One file. This we are explaining. We have created the structure here. We have read from the file. Then we have tried to print marks.roll and marks.t1 and marks. So we have obtained some unexpected zero extra values. Okay, you may remember that. I have at the initial stage of the class yesterday itself. Okay, I promised to explain those things. So this is the reason why it wasn't showing the actual result, because we are reading from the text file which was and we are reading the bytes and writing the bytes. When we enter our code is read and written, no, it will have no problem. But when we identify the components, the fields, this is why this is happening. Now we will continue further. Based on this background, we have now introduced till time yesterday. We haven't talked about the binary files. Now we have just introduced the binary files as well. Text. When we read a binary file, we can't cat text file. We can see the contents using a text editor. We can see its contents. C program is a text file. Or data files, which that is the marks.txt is a text file. So such files we can read. Such files we can edit using a text editor, but binary files cannot be edited using a text editor, because that is not at all a text file. Because the text file, when reading a file, will interpret each byte as a character and will read accordingly. But when we write into a file using structures, it will have a different interpretation to be applied there. That what structure is used to create that file, that knowledge is required to interpret that file also. Okay, we are dealing with those aspects now. Okay, let me check the name of the file which I have prepared for this explanation, this demonstration. Okay. Yes, June 8, let us keep 8, we have fwrite.c is the one which we have created yesterday. Now we will talk about fwrite m.c, that is meant for day June 9. Okay. Micro, we will see what are the contents, and we will learn some new file operators like if, seek, like that. Okay. frw file with m.c. Okay. Okay, this is a file. We will explain this file. Okay, we have opened two files. One is file in, and the file is declared two files for our process. Marks n dot text for reading. Okay, let us see what are the contents of marks n. Okay, let us see marks n dot text. Okay, I think that we have created towards ls minus le marks n dot text. N dot text. Okay. Okay. Let us see its content. Okay, it's a text file. It is a text file having. Okay, this is the file which we have used yesterday. Prior to this, we have this, only this. Then we have inserted this names or okay, just that much. Okay, so that file we are using here, and we are writing this data to marks em.text. Okay. Okay, then we have created defined the structure, the same structure yesterday. Structure marks student, roll number, name, field, 20 character length. So T1 float, the 4 bytes for that, T2 4 bytes, roll RN 4 bytes, float A1 float 4 bytes total. So total 20 plus 1, 2, 3, 4, 5, 5 into 4, 20 plus 40 bytes. The structure will take 40 bytes. This is relevant here when we use fread and fwrite operations. That much bytes will be written or redacted. Now fin file, while not end of the file fin, we will scanf %d. Okay, we have to we will scanf. Actually, that is what is meant for, not fread, for extracting the data properly from the text file. Scanf is recommended, and other text file functions. Fscanf, because normally the entries are separated by space. Okay, other means are also there, but to being the second semester, we are not going into the advanced things. We will read the contents from that file, and we will map it with this marks student structure. So this file have a roll number first. So we will scanf that marks roll number. Then it has names. Okay, marks name. Okay, name is 20 character my field. Then on the next line we will scan one next line. Okay, or we could have put it in the same line. Percentage of percentage of percentage of percentage. That means 4 floating point data entries on that line. Okay, 1, 2, 3, 4. So the first entry goes to marks T1, marks.T1, second to T2, third to A1, fourth to dot. Okay, this I think we are already familiar with fscanf. Okay, now we have created the structure properly, having the values. Okay, the structure will have roll number and all these fields filled and with the data taken the first record, first line of the marks n dot text file. Okay, so if just for the purpose of this see the size of this structure, we are just printing that value, okay, just for illustrative purpose. Then we now write fwrite marks this structure and its content, size how many, what is the size, how many, that means how many bytes and how many of such data one unit to a for. Okay, now even though it is marked as some dot text, it is written as dot text, it is actually a binary file. We will see after this. Now we are executing this while loop until f in the end of the file of f in. Then we will close this input file, we will close the output file, and we will reopen the file marks.marksem.txt, which we have created. You see, it is f out, f to which we have written this. Okay, so the entire data read from the text file marksem.txt is written using the structure into marksem.txt. Okay, okay. Then from the where we are reading it, while fread mark size of marks, the reading style. Then we are printing as before. Instead of this, you can see just we are printing the roll number and marks, total marks we are printing. Now the previous case we obtained zeros, that means for us is junk. Now let us see what output we are getting. Now we are going to compile this and execute this, and whatever I will explain things once again. Let us see the result. Okay, the name of the file you see is here is fwrite.c. Okay, we are in the same directory as this, so we will compiling that pcc -o. We will give the same name frwm.c. Okay, no errors, no warnings. Okay, and the output is generated at frwm. You may show ./frwm. Since my path settings allow me to execute without that. Okay, for WM, we will issue the program is executed. Okay, this is size equal to 40. Okay, this is here we have written 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines are there. 0 to 9, 10 lines are there. So each line will have a size 40. But if you are using text file writing, this will be different because all these names size are different. Okay, so this will be written as a stream of bytes or bits in this case. Okay, every character will have every field will have a fixed size of 40 bytes. Okay, now finally we have written the output. Instead of this junk here, we are getting the expected output 0, 1, 2, 3, 6, 7, 8, 9, and the corresponding values. These values are printed here. That is because we are reading the data from a binary file and written. Okay, which is the file created now, marksem.txt. It's not actually a text file. Okay, just kept that text section. That's all. Okay, let us see the what all of the files now created. ll -tr, the latest files. Last, that is the result of ls -ltr. T means time sort based sorting. R means the reverse order. I used to use that every time. So latest files will appear towards the end near the prompt. So marksem.txt is the file, last file, modified file, 1247. frwm, the compiled output, the executable. Okay, marksem.txt is the file created. That is this file. Okay, this file created. Let us see its content is marksem.txt. Is not readable. Okay, something familiar stuff further, but it is not readable because it is a stream of bytes written into that file using this fwrite statement. Okay, we have created the structure using by individually filling the fields from the scanf. We have read data from this text file and we have written the data to this file. Okay, so better since I have modified another file, this dot text extension is there. Okay, actually it's not a text file. Okay, so this is the content of the file. As we can interpret by it as a text file. When we apply cat, what it means, it will interpret the file as a text file, but it is not actually a proper text file. Even though the values there are could be interpreted as a text, but it is structured. The data is written using this structure. So if we use this structure to read the contents of that file, we could interpret it, but not as a regular text file. So that is why we were able to read the file. Okay, we were able to read the file using the fread statement. Now, if we print the name also, we will be able to see the control. We will insert that. Okay, percentage D, percentage yes, roll number, name. Okay, let us see. Let me hope it will work properly. Marks.rn. What is the next thing? Marks.name. Okay. Marks.name. Okay. I have tested it. Okay. Let me hope it will work properly. Marks.name. Okay. And let's compile. Already compiled. No error. Fortunately, let us execute it. The same old file is read and the same file is created. Okay, so now you see previously we have printed in the previous output. You see here we have displayed the roll number and final total marks, last call. Now we have modified that file and the formatting is required. Okay, our now purpose is not formatting, just to demonstrate that we could extract we could read the file, this file, this is my this file. Okay, we will again cat that. And okay, we are getting the same. This is the file. From this file, actually, we are extracting this data. Okay, that is through this statement, printf statement. Actually, we are reading it. We are reading. Okay, what exactly we are doing here? We will explain that. Okay, to how we have obtained this data, we will explain that also. We have first closed the file fin and effort, all files we have closed. Okay, we may insert an f close also after the while loop. Okay, that's a regular recommended practice. Fin. Okay, let it be there. What we have done, we have opened a proper text file. From there we have created another file, marks here some.txt, which we have, this is the content of that file. Then we have closed both this, then marks sm.txt we have opened for reading. Okay, clear. Now what we have read, we know that the contents of that file is created using the sys structure. So we need to use the same structure to properly extract the data. There is advantage of using this structure. So we could easily extract it using this. Other person who see this file will not be able to interpret what are its contents. Okay, since it is not a proper text file, even though the data is text, but it is a structured text file. Okay, now what we have done is okay, this is a fread operation. This is the read operation. From fread, what is that? This is the buffer to which we are reading. Marks is there is the sufficient space is there in the memory to accommodate this message. So to that marks buffer from the file pointed by fin, this one, we are opened it here. This many bytes, ones one file, one field, one reading of this many bytes we have read. Okay, that is, and that is assigned to the this buffer. So the data is now available in the Mars structure or Mars buffer. As far as the fread operation is called, this is an input buffer. The data is now there. How many bytes? 40 bytes. How it is determined? Because of this argument. Instead of 4 size of marks, you could use 40, no problem, but I recommended to use like this. And how many units of that? 1 unit from this file. Okay, now we have this marks ready. Okay, percentage D. First it is, we know the first field is okay. Anyway, we could interpret the marks is actually a structure. We know if we give marks Rn, it will take this one. If we give marks name, it will take this data. If we give marks dot this, it will print this data. If we print marks T2, this, it will print this data. Okay, so that is what we have done. Marks dot Rn percentage D display is to be displayed as decimal integer. It's a decimal integer. Okay, then marks dot name, it is a string name. Okay, percentages is the structure given. Percentage 5.3 after the decimal point 0.3 position. So if you make it 0.2, and will be a 0.50 like that. Okay, so marks dot is the data used there, that is there in this. Okay, so this is repeated as far as until we reach the end of the file. That is the fread operation fails. At the end of the file, it will return minus negative value. At that time, the while loop finishes. Okay, we will come out of this. So it is repeated from the start to finish. Okay, so that is the explanation of this file process. So we have now talked about binary files, creating, opening a text file and create. We have demonstrated creating a binary file. Yes, then close that file and then if used fread to extract the contents of the file, and also demonstrated that this file content cannot be interpreted using a text processor. Cat is a text file processor. It will display the contents of the file, but it is able to interpret it like this only. Okay. Now we will see another example. Let me check which file is to be opened. Okay. Okay, now we will learn some more binary file operations. Okay, for that the file is there. Okay, micro binary file operations .c. Okay, operations. Same structure is created. Okay, but we will learn some more file operation, rewind, fseek extra. Okay, rewind is that when a file is opened, if you read and reach somewhere down the stream binary file, rewind means it will start the operation from the beginning itself. Okay, this rewind, fseek and files are actually originated from olden days when storage media was largely tape. Tape is only a sequential access device. Magnetic tape, long tape, Now we have modern day faster semiconductor memory and other optical devices also we have, but previously it was magnetic tape were used. So once we reach that, by rolling the tape, once we reach the end of the tape of the plan, the reading should be planned in such a way that it will move regularly forward. Frequent move backward and forward movements should be avoided. So based on that, this wordings were used previously, and now still we are using it for binary files as well. So rewind means we will commence the there is a pointer in the file operation. Pointer will point to the initially at the beginning, and once some data is read, it will reach the end or somewhere in the middle. And a rewind means it will reset the pointer to the beginning of the file. Okay. Similarly, fseek and particular location in the file pointer will point to that particular location in the file. Okay, we will explain that also. Meanwhile, let us have this man page of all this. Okay, rewind over. One will do. Okay, see, fseek the file from where, whence, and how many bytes. Okay, and we will see that. And rewind. Okay, just give the name of the file. It will rewind. We will use these two for the time being, fseek and rewind. We will use in this illustration. Okay, so now come back to this file. We have opened the rcm.txt file. That is the file we have created just before, and it's a binary file even. Okay, and we are using the same structure, and we are reading it and printing some data. Okay, fread size of marks on a similar statement. Okay, and we will read the data, every data, and print the roll number and total marks of the student, just for one action, just to make the file pointer move towards the end. Okay, now the file is at the end of the file. Now if you rewind it, the file pointer will point to the beginning of the file. Okay, and then again we will do the same command. We will get the same result. Okay, we will compile it and run it and see that those result, and the rest we will explain immediately. Okay, CEC what is the name of the file? Binary file operations.c. Okay, binary file operations.c. Okay, okay, compiled. We will run it. bfos. Okay, that we will explain. Okay, initial stage this 0 to 9 at point. That is because of this while loop. Okay. Again, we have after the rewind operation, we are executing the same loop. Again, the data is read and we have printed everything again. Now we are again applied a rewind. That means the file pointer is reset it to the beginning of the file. Now we are reading the file from particular location only. We are not reading the entire structure. Okay, we could read the entire file structure, one structure, and marks as here, and we could separate the contents. Okay, that is possible, but there are situations where fseek is applied. To demonstrate that, we are here. We are applying the fseek command. The structure fseek is okay. We will rerun that. Man rewind will show fseek also. Okay. Okay. what it is doing, we will explain here. fseek, the file name pointer, this one. Okay, we have opened it for reading, and it will should skip this much bytes. The first field is our intention is to read the name. Okay, only read the names, and we are not reading nothing. So in this file, so many data are there, but presently we are interested in reading the names only. So we are not reading other data. We are reading the names only. It's a little advanced topic. I wasn't sure whether it is to be taught at the S2 level or not. Anyway, since it is there in the syllabus about fseek extra, we should discuss this. Okay, learn it. Okay, it will be in computer science. Definitely, we should understand it well and should be able to apply it. Okay, size of marks.r. That is, we are skipping this roll number because the name is the second field. So we need to skip this. So that much bytes we are skipping. So initially that we are doing fseek, move the file pointer this much space. Okay, from the start, where from where we have to do that. Seek set. That is from where we have three indicators, that is seek set, seek current, seek end. Seek set means from the beginning. Okay, we are moving the file pointer, okay, from the beginning by this much bytes. Size of marks.rn. Marks means 40 bytes. Rn means this much, 4 bytes. Okay, we are not using 4 here, but we are reading whatever be the size of this Rn, that much bytes, saying 4 bytes. So from where? That is whence. From where? From the beginning, there we can have three values: 0, 1, 2 integer values, or seek set. These are constants there in the header file. Seek set, seek current, seek end. Set means beginning, current means where the current pointer is pointed to, seek end means from the end of the file. Okay, so we are moving that we have done. So to start this while loop, what we are doing in this while loop is, okay, we are reading and displaying only the name field. Okay, that is what we are doing here. Okay, so first we are pointing to first name. Okay, you remember the structure of the marks m dot text, roll number, name, 3 subject, test T1 marks, T2 marks, total marks of one student, the next student, and so on. So the second field is the name. Okay, so the first we have set the pointer point to skipping the marks dot rn. After rn, what we have is name. So the pointer is name pointing to the name field. Okay, now fread. Now from the we are reading not the entire data but only the name. Okay, marks name is the buffer name, that is this marks. Within that name, marks name, to which we are reading how many bytes. Size of marks dot name, that is 20 bytes. Size of marks dot name, one such by field we are reading from fn. Okay, we will read it as far as this read is successful, or as far as we are successfully read means we are within the file itself. Okay, now we will put that. Puts means put that string onto the output device, and now we will fseek again. Okay, the difference between this fseek and this we will fill. For that file, size of marks minus size of marks minus name, seek current. From the current position, okay, one name is displayed. Then we have to move to the next line. That means we have to move to the next record. Next record is reached if you skip the size of marks once minus size of marks name. because the current, the pointer is pointing, once we have read the first name of the first line, okay, we will explain, okay. We will cat n dot text, okay. Okay, this is the structure of file. Okay, this file is we have read and written to marcm.text. Okay, okay. What we have done is we have read maximum in this first reading from here. Okay, okay. Then the currently the pointer is pointing at the end of em, and that there is no space in that. Okay, 20 characters will be there, and it will be pointing here. Okay. After 20 characters, it will be pointing to at the beginning of this 20, this mark T1. Now, when we to read the next, what we have to do, we have to reach from here the current point. The file pointer should move from this position to this position, from here to here. So what we will do is we will advance by one record space, that is the enter space minus this much space. That is what we have done. Of fseek in that file, size of marks minus size of marks name. The size of the name field, that is the total file is 40 minus 20. 20 is actually, so it will skip 20 characters to reach here. Okay. 1, 2, 3, 4, 5 into 4, 20. That is why it is 20. But we are not actually hard coding the actual value. We are doing it like this for safety. Okay. Size of marks minus size of marks dot name. Some of you may have some difficulty in understanding this explanation, but discuss with yourself, ask me later, or try to experiment. What actually I am doing, trying to explain is we have read this much mark, this mark string, the name of a student, and then we have skipped it to the next record, and when we skip to the next record, that is size of marks fseek, we will reach here, or we could do it in other way methods as well. Anyway, this is the method we have applied here. We will reach here, but we need to read the name from the beginning. Okay, so for that we know the size of the name field should be traced back. So what we will do is, while skipping, we will calculate this length, and then we will subtract this length, and we will advance that much. Okay, that is why fseek fn size of marks minus size of marks dot name. So from where previously it was from the set beginning, from the current position, seek current, or it should be 1. Okay, that way. We will read that, we will write next, we will put that, and just to put some delay, we have put a get char. Okay, we will execute it, the same program. Now we will see. Okay. BFOPS, BFOPS. Okay. You see, maximum we have, this we have already explained. Maximum we have read, maximum is the first name that we have displayed. Then we are, because of the get char, it is waiting. We have printed, okay, hit the enter button. Next name is read and displayed. Okay, because of this operation. Okay, we are only now interested to read the name fields of this structure. We are reading directly from the file. We are not reading the entire structure. We are reading only this much data. There may be series. So fseek is a such a used for such purpose. That is the file pointer. Within that file, there is a pointer pointing to the current location where we have to do the read or write operation. That pointer could be moved using the fseek operation that we are learning now. Okay, enter, don't type that. Okay, last person is also read. The next read after that, if the next read operation will fail, and we will finish the operation, and that's it. Okay. I planned to demonstrate one more program, but I think this is, I feel that is more than enough for the day. Okay. So we will explain once again in a nutshell what we have learned. Before that, let me take a break, 1 minute. If you have any query, raise your voice. for texting. After that, I will continue the explanation. Let me copy the attendance inputs. Okay. Okay. Let me check any message. Nothing. Any point to be explained further about what we have explained? Please type in or ask now. Else I will conclude that. Many of you have understood. I have explained, or you will hope will be able to complete the learning process between yourself or by other means. Okay, or if you have some doubt, you will ask later. Okay, so we will complete the explanation. Other operations will discuss next day. This is sufficient enough. What we have done here is we have demonstrated the fseek operation. That is there is a point. Okay, we will like the man page man fseek or and everything will load the same file. Okay, fseek. Okay, you see fseek function sets the file position indicator. I have used the word file pointer. Okay, both will be file position indicator for the stream pointed to by stream. The new position measured in bytes is obtained by adding offset bytes. This is the offset we have used here as the size. Okay, of the marks and the marks not any extra. Bytes to the position specified by whence. Whence is three values are there 0, 1, 2. That is seek set. The whence set is seek set, seek current or seek end, a current value or an beginning of the file or end of the file. The offset is relative to the start of the file, the current position indicator, end of file respectively. So the offset is from where? From the offset is relative. That is from the end or from the, how many bytes from the end or how many bytes from the current location, how many bytes away from the starting location. Okay. Okay, successful call to the fseek function clears the end of file indicator for the stream and understanding. Okay, that we immediately we needn't worry. Okay. Okay, that much only is written. Also, the file pointer or the file position indicator as written in the man page. Okay, if you have any doubt about any page, use man page extensively. That is man command. Even the commands are there and the functions within the C program are all are available through man page. Okay. For the same command, there may be more than one page. In that case, which man page you are referring, you could give it like this: fseek2 man 12. There is only one fseek here. There is no entry in the 2. Suppose in that case, it will display. Okay. For the time being, our focus is here. Forget about that. Okay. Now, here if it is the third man page, man 1 3 fseek or man 1 fseek, like that, more than one, you will get it. Anyway. So fseek is that it is we have to position tell the program from where beginning, middle or end, middle, not exactly middle, the current position, and how many bytes of this file string, and the file current locator, file pointer will point to that location, and the next operation, read or write operation, will commence from that position. Here you see within that file so many data are there. Structured data written by ourselves or marksium.txt is created by us. It's like, okay, by reading data from marksium.txt, and we are once the data is available at many time, we at one point of time we may be interested in reading the marks, at another time we may be interested in reading the roll numbers. Now suppose we are interested in reading the name only. This is the program for that. So to apply fread and fwrite and fseek extra, we should have a clear idea about the structure of the file, what structure is written to the file. Okay, other people won't be able to interpret and process it properly. Okay, so hope that will do for the day. Thank you for listening. Okay. Any doubts you could raise now? You could type in now. Otherwise, I will wait for a few minutes and leave. After that, if you want, you could discuss between yourself, or you may leave now. Up to you. Okay, let us stop the streaming.